Thank you, Jenny, for the introduction. Hello, everybody. I'm quite impressed by the number of people that are still in the web conference. So thank you all and welcome. So our presentation is called "Keep Them Out of the Database." It's quite an abstract title. So just a quick introduction. Actually, it all started on Twitter. So before DOAG 2018, it's a big Oracle conference in Germany. Martin and I planned to attend. And actually, I reached out to him with a Twitter message to ask about Connection Manager, because at my job at this moment, I was looking for a solution to keep everybody out of the database. And we had many conversations during the conference, several times about several topics and several solutions. And then Martin had the great idea to turn our conversations into this presentation. So I will let you introduce yourself.
Yes, before we start with the presentation itself, some words about ourselves. So my name is Martin Berger. I'm with Oracle since 20 years now. At the moment, I'm working for Trivadis, same company as Chris presented already, so I don't need to say anything about it anymore. If you want to reach out to me, you can use Twitter, you can use emails. I'm also blogging something, and I'm allowed to speak here today because I'm Oracle Ace, but this only says I like to talk about something. It's not quality label at all. So that's more or less all about me.
Martin, can you try to increase the volume of your microphone somehow?
Yes, I will try this.
Thank you.
Okay, is it any different now?
To me, it's okay. I can hear you perfectly.
I can hear you fine. Yeah, and people say apparently it's better. Okay, thank you.
Okay, sorry for this.
Thank you.
Flora, it's your turn.
Okay, sorry. So my name is Flora Barriele. I am French, but I live in Switzerland. I've been in IT for 8 years and 4 years as a DBA. I love my job so much that I became a co-organizer of a meetup group called Geek Girls Carrots, and we aim at promoting women in science and technologies. I work for a company who is called SwissQuote. It's a Swiss banking group specialized in online financial and trading services. I've been recently, I entered the Oracle ACE program as an ACE associate, and I also have a blog. So how did all started? So Martin asked me a few questions at the beginning of our conversations, like this one.
Yes, you can imagine at the conference, it's crowded and everyone has different interests. So it was not a organized structure how to discuss this topic, but I quite early started. So why do you want to keep them out? It's more a network issue. Every company has network admins, firewalls, anything. So why not ask them to create the firewall rules? That's what they can do best.
And actually, my answer was more or less this one. So it was a long process to involve the network team in this project, and it was not possible at the moment to ask the network admins to filter the connections with the firewall or other means that they had at the moment. So Martin's next question was,
yes, we can still create a dedicated listener for each instance. It's some work, but this can be scripted, can be done easily. And then at least on the listener, we have some chance to allow or disallow who is reaching the instance. Is this sufficient?
And for this, once again, my answer was more or less, sounds difficult, because at the moment we have more than 600 databases spread across 65 hosts, more or less. So it sounded a little bit difficult to have a dedicated listener for each of these instances.
This was the first time where we decided to do a more structured approach and yeah, try to understand what really is needed for the whole situation. And at the end, it comes down to 3 points, and you probably know these words, these buzzwords already. On the left side, we have the users. On the right side, we have the databases, and in between, to connect both of them, I call them roles. So maybe it's not the role as you have it in an Oracle database, but more in an organization. And it can be any kind of role, like a DBA, as many of you might are, or a developer, or the one guy who knows the whole IT in the company and can fix everything. This is also a role at the end. And it's never clever to assign something, some credentials or access to the user directly. It's much easier at the end to have dedicated roles. And if it's called the one guy who knows the IT best, this is still a role. So that's what the background is at the beginning.
So after these more relevant questions, the real question was how to handle the situation better. And actually, the most important thing that Martin told me is that I have to know and understand my ecosystem. So the best approach to start a project like this is really to grasp and understand everything that is going on the IT system that I'm working on. So I'm going to show you how I achieved this with an example with Splunk. So to better understand the ecosystem, I have to know how many DBs I have on how many servers, which versions are those DBs, how many different users, how many different application servers, how many different applications. To make it short, I have to know who connects where. So instead of using things like grep, we can use modern and powerful tools like Splunk. So this presentation will not be about Splunk, but just to let you know, Splunk is a powerful tool to collect and index real-time data from a huge amount of sources. So you can think about log files. And this solution is actually cheap in terms of effort, and the results are really handy and easy to exploit. So how can we make the best use of Splunk in this case? Actually, Splunk comes with a very, very interesting add-on for Oracle database. And this add-on is able to parse things like alert log, audit logs, and of course, listener logs. So listener logs can be a very rich source of information. And of course, combined with the power of Splunk, the results are quite impressive. So I'm going to show you 2 examples of dashboard that have been made with Splunk in the combination of this very interesting add-on to parse the listener logs. And I'm going to show you 2 examples of what we can get. So for example, with a very simple Splunk query, you can get the number of connections to a specific service, think Oracle service, or to a specific SID by source IP. So in this example, you have a service called cool service, and it has been accessed by the IP 1234 a certain amount of time, and the same for the service called nice service by the IP address 4321, 2000 times, etc., etc. So it is very convenient, and it's really easy to get relevant results. So I want to show you another dashboard that was very useful also. So on this one, I'm not sure if you can read because it's maybe a little small, but you have 3 different parts. On the first one, you can see a chart with the number of connections to production databases and showed by host. So you can see, for example, that host number 5 has way more connection than other hosts. The second part is the number of connection by service name. So you can see that on host 5, the services that are called cool service and nice service are a way lot more used than other services, for example. I'm sorry I had to blur everything because that's sensitive data, but I think you get the point. And the last one is actually my favorite one, because the last part shows how many connections by host to specific SIDs. And actually, I used this chart to boost applications that were connected to SIDs directly, because we really want to avoid that. So with this tool, it was very simple to have nice and visual dashboard. So at a glance, you can determine which server receives the most connections on which SID or which service. For example, you can do whatever you want with all the logs that you want. And to be honest, managers really liked that kind of dashboard. So all these examples show us that the most important concept is to choose a solution that fits my needs or the needs of your IT organizations. And with technical solutions like this, you can have a better idea of what kind of solutions you will have to implement and what kind of problem you will have to face. So in my case, what was the problem? So actually, the problem was this. So I'm the guy in the middle. Actually, the problem is that everybody is Waldo. You cannot distinguish people from each other. You have many different people across many different departments, many different responsibilities, even on different networks. You have a lot of different applications. You may know this, but sometimes you have people that are nice enough to share their credentials with their friends. We don't like that. So the key point is that responsibilities are not very well distinguished in such a chaotic setting. So how can we address that? How can we address this problem, this Waldo situation? What kind of technical solutions do we have? So this question was the main question of our conversation with Martin. And we discussed different solutions. And this is what we are going to explain now. So Martin, you can take the presenter role.
Yes. So now let's talk about the connection manager. Come on. Here it is. So the connection manager has basically two main components. It's the listener on the one side, and there are gateway processes on the other side. It can run on the same host as a database, but it's not required. It can be installed totally independent. To keep the setup simple, the database registers itself to the connection manager, so it needs to know about it. That's normally done via the remote listener configuration in SP file. And on connection manager side itself, there is a rule set with a lot of rules, what's allowed and what's forbidden. A connection from the client then first connects to the listener, as it does normally. This listener checks for the rule sets, and if it's allowed, hand over the connection to the gateway processes, and those connect to the database instance. If I want to be more precise, I would need to draw a second listener here as well, but then it would be too clustered, I guess. So here we have some examples about the rule set. It's normally a line like this, so you might recognize the format when you have ever edited TNSM's or something similar. We have some rules with source and destination, with the service and the action. The source and destination can be either host names, like here in the source example, or it can be an IP address, like in the destination, or even an IP address with a net mask. So if your hosts are grouped clever by the network guys at the beginning, then you can use one rule for several hosts. The service is exactly the service we know from the normal database listener, and the activities are either accept, reject, or drop. Accept is easy. Let's just connect to the database. Reject and drop create different errors then. As we have, if it rejects, you get some information. It says you're really not allowed based on the rule set. A drop is a simple connection closed. You don't have any idea on the client side what's going on. And if there is no service registered at the moment because the instance is not running and it did not communicate to the connection manager's listener, then it's the simple error message you know already. Listener does not currently know the service requested in connect descriptor. There's no difference there as well. If you want to have the whole setup in higher availability, you can easily create two settings or several settings of connection managers. They can reside on the same host, but if you want to achieve higher availability, maybe different hosts are reasonable. Then the client can decide to connect to either of them. Then the client can connect to either of them. The rules are applied, and then the connection is forwarded via the gateway processes to the target instance. Please take in mind these different rule sets on each connection manager are not synchronized automatically. Oracle does not provide any method for us, so we need to take care to have the same rule set on all connection managers which serve for the same purpose. The connection on the client side is similar to the high availability connection sets we know from the past, with an address list and different addresses for each of those connection managers. At the end, the client cannot distinguish if this is a real setting of connection managers or an old style real availability cluster, similar things. It's always a listener.
Okay, so I'm going to take over the presentation, but first I would like to answer two questions that were asked. And for the third one, I think you will have a beginning of answer later in the presentation. But the first question is, Splunk is open source or need to buy license? So there is a licensing model for Splunk, and it depends on the volume of data that is processed. I will find the link after the presentation that shows the different licensing model. About the second question, it's could you please share any blog YouTube link for opening listener log using Splunk? I will find something after the presentation. Actually, I blogged about using listener log in Splunk, so I'm going to self-promote, but I'm not sure it's going to answer all your questions, so I'm going to find some more material. And about the third question, I think we can answer it maybe at another moment of the presentation because you will have more, more info. And thank you for the person who posted the blog post. So I'm going to share my screen again. So we talked about different solutions with Martin. The first one was Connection Manager. And the second one we talked about is called Database Firewall Service Access Control List. So it's quite a long name for this feature. For the rest of the presentation, I'm going to call it ACL because it's a little bit shorter. So first of all, it's a new feature and it started with Oracle 12.2. So keep this in mind. So I'm going to explain you the concept. Imagine you have two people, Waldo and Odlo. Odlo is the bad guy from the Waldo books. They both have their own PDB in a CDB. So Waldo has its own PDB called Waldo, and he has the Waldo service on the PDB. Odlo has Odlo service on his own PDB. And we want to make sure that they both connect to their own PDB, but we don't want them to connect on the other person PDB. So to achieve this, there is this new feature that allows to control a specific service of a database or all the services of a PDB with an access control list. So actually, it's a list where you can keep the entries with the hosts that are allowed to connect to the PDB or to a service. And actually, it's not multi-tenant specific. So you can use it with a non-CDB to protect a specific service. But with multi-tenant, there is something very convenient, is that you can protect the whole PDB at once. So if your PDB has several services, let's say service A, B, C, you don't have to protect service A and B and C, you can protect the whole PDB. But the idea is the same. So you can specify an access list to protect a service. And it allows fine-grained access, and specifically with PDBs, you can have a fine-grained access on each PDB regardless of the policies on other PDBs. So keep in mind that it started in 12.2. And to implement this feature, you have to perform some modification on the local listener that is handling your database, so your CDB or non-CDB. So I'm going to show you a quick example of how it works when an IP address or a host is not allowed to connect. So if you try to connect with an unauthorized IP, you're going to get this error. It's really easy to understand. It says TNS listener rejected connection based on Service ACL filtering. So it tells you why it has been rejected. So why would you use this? So like I said, it's available only starting from 12.2, but it allows you to have fine-grained access control on each database or PDB. It is very flexible because you can specify an IP address or a range of IP addresses using a wildcard, but the management is decentralized. It means that you have to specify the authorization, the entries in every database. So if you have 100 databases, you have to put the list in all of them. So now that we explored those two options, and one of them is available only starting from 12.2, what other options do we have And what can we do if we have, for example, database still in 11.204?
I'm taking over the screen again. So a total different possibility are logon triggers. While ACLs are very new, or in fact 12.2 is out for some years, but I'm sure most of you still have some older databases available as well. Logon triggers are there for ages. And on some layers, we can compare them to the ACLs. So a short introduction about the concept that what can be done or should be done with the logon triggers. We can check at each and every connection for the user's host name, the web operating system username or the terminal, the application module or the IP address. Unfortunately, all these informations can be tampered if the attacker knows what he is doing. So it's not perfect, but for several reasons, it's often good enough to decide based on this if someone is allowed to connect to a database or not. Similar to the ACLs, you need to have a map table on each and every database who is allowed to connect with which database user and who is not. So it suffers the same problem that if you have 300 databases, you need to distribute your configuration to all of them, keep them up to date, and it can be quite complicated. The trigger itself then might be quite easy, and just check if it's allowed to connect from the specific host name or IP address or whatever you decide to the user you want to have. There's an example for trigger. The most important part is highlighted here. If the check doesn't match, just throw any error, and this is shown to the application who tries to connect to the instance, and that's it. So you can decide what to tell your client, why they go away, or even where they should ask for allowance to this particular database. So here you're more flexible with your error codes than with ACL. So there are several reasons why to do it. Let's start at the end. If you want to use logon triggers, don't forget to log what you're doing, especially if you reject something. It's very wise to have this information. This can help if you need to analyze a possible attack or even a scan later on. Or even if someone claims that it's not working, it's good to have a log what the trigger did and why it did it that way. It's problematic because it's decentralized, similar to the ACLs, so it does not easy this part of the whole setup. But it works with very old versions already. So I'm quite sure every database version out there at the moment support logon triggers. And if you don't rely on some fancy features, then the code should be very easy, very stable, and simple to maintain. A total different approach can be auditing and reports. So let's first talk about reports. I'm sure most technicians like reports, like hell probably. We need to fill them for some managers that they get information by week or by month, and this is boring most of the time. But in this case, we can turn them around to our advantage. We can give reports to the manager, and they need to react to them then. So first about audit. We have the conventional audit, which is in the database again for several versions. I don't know by heart when it started, but it's there, it's working, and quite simple to set up. At least you need to have audit and logon. And the interesting part is you can then create a report for the user's manager, this user connected to that database with this timestamp or that username, that operating system, and then put it on the manager's desk to decide if this activity was correct or not. So then they have their daily or weekly audit and need to decide if their people are doing the right thing. But there is more you can do. You can use a unified audit. This is available since 12.1, but I highly recommend not to use it before 12.2, as there were some performance issues with unified audit in 12.1. If you set up audit already, then maybe you want to audit some more things than only the log on required. Of course, the next thing is log off can be of some interest, but I saw it quite useful to audit also all or at least most of the DML statements. This has nothing to do to keep people out of the database, but it's often easy for a DBA to answer questions based on this audit, like why did this index disappear? Or who changed this package? And then you can easily see what connection was used to drop this index or change the package. And you can inform the person who's asking, see, just go to your colleague with this login from that host, from this PC. He changed it yesterday at 10:15. So maybe there was a planned change for this. And if it wasn't, don't bother the DBA, fix your process in your team. It's easy as it is. And the reports, maybe they should not go to the manager of the users, because they will always have good excuses why their people really needed to do this work. Maybe it's more clever to put it onto the application manager or a security manager. They often have more interest to follow the rules the company is giving itself. And they will also challenge the user's manager if their people are not following these rules. Flora?
Okay, so I'm going to take the presentation. Okay, so yes, this screen. Oops, sorry. Okay, there. Okay. So we explored several solutions, like Martin said, and those solutions are more or less available depending on the version of your database. But actually, after that, we thought about combining two of those solutions, and that would be combining Connection Manager and the ACL feature. So how can we combine those two solutions to fit our needs? This is what is being studied right now, both on a technical perspective and management perspective. So I'm going to explain you how what is currently tested. It has not been implemented, totally implemented yet. It may not be a final solution. Discussions are still ongoing, but this is what we thought about. So first, consider we are using grid infrastructure. So we must consider that we have local listeners on each servers and also scan listeners. So in this example, you have 3 people that look really nice, and they should be allowed to connect to those databases that we see at the bottom of the screen. The idea is to use Connection Manager between the user connections and the databases to filter who is allowed to connect And then the idea is on each database to have only one rule. And this rule would be only connection manager is allowed to connect to the database. So actually, the real architecture is not like that, because we would have a single point of failure. So actually, we have 3 connection managers behind a virtual IP. So, okay, that's clever. You can connect to connection manager and then the connection is redirected to the database. But what happens if someone has a bad idea? And for example, let's say Odlo wants to connect to the databases and connection manager says, no, he can't. But what if he's clever enough and he wants to connect directly to the scan listeners? Then he wouldn't be able, because the ACL would prevent this action, because they would only allow connection manager to connect directly to the databases. What if we have some databases that are still with version, for example, 11.2. So for those versions, ACL is not available, but we could implement protection with a parameter in SQLnet.Aura called tcp.invitedNodes to specify which clients have the access allowed. But there is still a very important question. Who takes decision about security policies? Do we want, as DBAs, to take this responsibility? Do we want to take those decisions? Do we want to see people coming to our desk and say, can you give me the access to this? And we don't want to have to say yes or no. We don't know. So now we want to give back the responsibility to the security team. We want the security team to take the decision, and we just want to implement the technical solution. We don't want to have to decide anything. So the idea we had, and that is being currently implemented, is an application using Oracle Application Express, so Apex. And I'm going to show you the concept behind this Apex application. So you see our architecture, and on the right, you see that we have Wilma, and Wilma is the security officer. And we want to give her a simple Apex application so that she can insert the new access policies in the application. We don't want DBAs to do that. We want the security officer to do it by themselves. And then we want to implement, let's say, every night, we want to update the connection manager rules based on what the security officer added in the app, so that the DBAs don't take responsibility. Wilma add rules or remove the rules, and then the next night, or for example, in the next 15 minutes, we want to update the rules in connection manager. So the idea is that we have the application, and behind this, we have a map table. And this map table is actually a very simple table with all the rules that the security officer decided. And then, like I said, every night or every 15 minutes, depending on what you want, the rules in the connection manager will be updated thanks to the information in this map table. So to show you a very simple example, it's actually what I'm working on. So we would go from this. So this rule list is exactly what Martin showed before in the connection manager part. So we have a list of rules. And we have, for example, the source 1234 that is allowed to connect to destination host 1 on service called cool service, and the action is accept, so it's allowed. We have a second similar rule, and for example, we have a very privileged server, and this server is allowed to connect to all the services on a specific destination, etc., etc. So exactly the connection manager rules. And at the end, we want to say by default, we are going to reject the rest. So actually, it's pretty simple to translate this into a simple table like this with various columns. So you have the ID of the rule, for example. You have the source. So the source is the source host. You have the destination. You have the service. You have the action. So for example, accept or reject. You have the rule order, and I'm going to go back to the rule order in 2 minutes. You have a description because, of course, you wanna track your modifications and you want to put the ticket number in this. And you have the update date because you want to keep track of everything. So why is the rule order important? Because Connection Manager is going to read the rules in this specific order, and you want to keep this logic even in your table. So the last rule, for example, the rule number 999 will be reject everything. That's why this column is important. So now the key points of all those conversations, what are they? So first, we agreed on the fact that the centralized deployment would be way easier with Connection Manager because you can handle all the rules in the Connection Manager configuration. But we also have a simpler configuration that can be achieved on all databases servers if we want. So we could also say we use ACL for specific servers and we don't need Connection Manager. That could be a possibility. The most important thing to understand is that before implementing or choosing a solution, we want to get to know our environments and we want to have a good idea of the whole ecosystem, of the whole who is connecting where, who is doing what, to help us make the right decision. We also want to make sure that a solution fits our needs. Sometimes solutions are really, really interesting to implement, really fun to play with, but sometimes they don't really fit our needs. So we want to consider this, and we want to keep things as simple as possible, especially for every team involved in the process. So we want to keep the solution, the architecture simple for network team, for database team, for architects, for developers. We want to keep everything simple for everybody, not only for the DBAs. We also want to help the users and assist them in embracing the changes. So that's why involving the security team and telling them, we cannot take the responsibility on the rules. We want to give you this tool to help you do your job. This is really important to assist everybody in this kind of project. And also, it's not only about DBAs, like I said, it's also about non-technical things to consider, and sometimes it's about political matters. So there is not one solution to rule them all, but we need to find something that fits our needs. And we are techies, but we must juggle with a lot of non-tech problems. So it's all about the choice of a solution that would fit your specific situation and our specific situation. Martin, do you want to add something?
Maybe we can start with the question and answers. So
okay.
I will pick the first one. If SEMEN creates a single point of failure, and well, if you only have one SEMEN, then yes. But as Flora showed in this picture, just a second, you can have, yes, here it is. You can have several of them. You can have several connection managers, and all of them can serve for connections from the clients to a database. But unfortunately, they are not synchronized with each other, so you need to deploy the same rule sets to all of them. If you have a setting like Flora has in the company, then it's easy to deploy the rule set to all of them. But if you do it manually, be very careful. The rule set does not become asynchronous. Okay, there is another question. Was OID, EUS, OUD, LDAP not an option for the company? Flora, do you want to answer those?
Yes, I would like to. So this question is very relevant. And actually, we did consider those options. Maybe not all of them, but OID for sure and OUD, of course. So like we said at the beginning, those are some solutions that we discussed in details with Martin and that were relevant for this specific project. But I totally agree with you. Those other options could work depending on, for example, your infrastructure, the licensing and things like that, but definitely they could be options. And the second part of the question is why preference for Splunk and ACL DB PDB? So Splunk was the way we used to grasp the situation. So Splunk was more of a mean to understand the whole ecosystem. We could do it with any other solution. We could also take all the listener logs and grab all the IP addresses, for example. But this solution was already implemented in my company. The other administrators that were using Splunk were very into it and they helped us implement the listener log part. So it was very convenient. And that's why Splunk was the tool of choice. But of course, you can use anything that can get some relevant data from your logs or your trace files. Okay, so I see another question. Hello, and thanks for your presentation. Thank you for attending the presentation. Does DB Firewall ACL require an extra option? I'm 90% sure no, but I always want to check those licensing questions.
Okay, there's another question. I remember I implemented ACL in 11.2 using something like dbms_network_ACL_admin. Or are we talking about something else? Yes, these ACLs are for outgoing connectivities from the database to other IP addresses or something. You might need this to access an email server or REST service from within PL/SQL. But Flora was talking about incoming connectivity, and this starts with 12.2.
Okay, so I think the second question was, are we talking about something else? And I think Martin just answered that, yes, it was something else. I'm sorry, I feel like I click anywhere in the questions and I'm afraid I'm going to do a mess.
It's all good, don't worry, you're doing it
okay. Great. Thank you. Thank you.
So I will take the next one. Is SEMEN also like a centralized TNS repository for all users' databases? Or every user still have to have its own TNS names aura? Connection Manager is not like a centralized directory like an LDAP or similar. So all your users need to have the same local TNS configuration or your centralized directory, whatever you had before. You only need to redirect them to the new SEMEN servers. But the distribution of connection strings is the same way you did it before, no change there. And maybe the next one, is there a limit of number of SEMEN? Honestly, I don't know about any limit to have several connection managers side by side, especially as they are working independent. So from this perspective, they scale. There are limits in each of them, how many workers they spawn and how many connections each worker can do. So you need to balance this, of course. And it's always a question how strong the machine where the SEMEN is running really is. So how many connections it can handle. But basically there is no number of limit for SEMEN I'm aware about.
Okay, I can take next question. Is SEMEN plus ACL solution still applicable to cloud environments like OCI, AWS, etc.? I'm absolutely not a cloud expert. And I would say depending on the solution you can have in the cloud, it's still applicable. You could use them, of course, depending on the level of service that you have and on the whole architecture that you're implementing. But those solutions work with regular databases and cloud databases. Do you want to add something, Martin?
I'm also not a cloud expert, so I have nothing to add there.
Okay.
So I take the next one. Does changing rules list or any other SEMEN configuration require its restart involving any service downtime? Basically, it's a listener, and a listener can reload its configuration while it's running. And it's exactly what you're doing. You reload a new configuration file, and from this moment onwards, it's doing exactly what it's required to do. And you also need to consider you not only have the listener, you have the worker processes. So even if the listener process has some issues, the worker still can handle existing connections. So these are separated as well.
Okay, so the next question is, maybe in small environment, proper IP filtering on listener.aura, SQLnet.aura is more proper. So I think I get this question like, maybe we can use simpler solutions in smaller environments and simpler environments. And I totally agree with you. You have more than the solutions that we presented today to avoid the connection to a database. You have a lot of different solutions. And exactly, if you're in a small environment, you maybe want to implement something different and simpler. So that would work.
So I'll pick the next one. It's according to presentation for data guard setup, primary standby connections need to be also established via SEMEN as other connections are blocked. Have I got it right? Well, here the correct answer is it depends. In this case, it depends about your configuration. You always can whitelist connectivity between primary and standby. And in fact, I would recommend to whitelist them and let them communicate to each other. But this can also be secured by using dedicated listeners or ports or similar, and not to pull all this data via the connection manager. But if you take the picture we are showing here right now in a very strict way, you're right. In that case, all connection must go via SEMEN. But this is only the way anyone would configure it in detail.
Okay, so next question is, thank you for the beautiful presentation. Thank you for attending. One more question. Is there any way to prevent allow connections between PDBs in one CDB? Of course, it is possible to use triggers already mentioned, but probably there is one more strict solution. That's an excellent question. I didn't try to prevent inside one CDB. I'm sure there are things that you can implement. I have to test this with the ACL solution because you have different parameters to consider. So for the moment, I cannot give you a proper answer.
A future blog post?
Sorry?
A future blog post?
Yeah, maybe. Thank you for the idea.
Okay, so the next one is to route application connections to SEMEN. Do we need to consider any driver compatibility? Yes. You can see the SEMEN as a server process from the application perspective. So all requirements for compatibility between the client and the server apply there as well. And on the other side, the connectivity from SEMEN to the instance has the same requirements. In this case, the SEMEN is the client process. So you still need to follow the same compatibility requirements you have between a simple client and a server, but it can be slightly easier to have a SEMEN in between, which follows both the client and the server's requirements when the client and the server cannot connect directly anymore.
Okay, and the last one is not a question, but very nice words that thank us and all the organizers. I would like to thank you, Martin, and thank all the organizers too.
Thank you as well. Thanks, Johnny, for organizing this great event.
Yes, thank you, Jenny.
Hello. Thank you very much, Flora and Martin, for your presentation.